I'm Hiranya Abeyrath, technical lead at WSO2. So, welcome everyone to my session today. So, today I want to talk about a problem many AI teams, AI organizations facing once their AI systems move from prototype to production, right? So, most organizations think they have model cost problem, but what they actually have is architectural problem sitting around the model, right? So, as AI systems gain access to the model, access to the tools, enterprise systems or APIs, so more and more orchestration logics move into the model. So, it's really hard to govern that, right? So, LLM is no longer just reasoning, it is selecting tools, coordinating execution and retry upon failures and driving the workflows, right? So, driving the execution. So, today I want you to understand how we can get rid of this problem using control plane architecture, right? So, let's start with a concrete example. So, here imagine a bank has deployed an AI agent to handle different type of fraud alerts. So, depending on the situation, it might be triage the alert or start a fraud investigation or analyze the linked accounts or apply temporary account restriction or prepare a suspicious activity report. So, from the business perspective, this really powerful. So, one alert comes into the agent and agent reasoning over it and select the appropriate capability, right. So, the real question is what is actually happening behind the scene, right. So, let us focus on one workflow or business workflow, fraud case investigation. So, underneath that workflow involves multiple tools, multiple API calls, multiple decisions, multiple rounds of reasoning, right. So, in the one fraudulent investigation workflow, it first pulls transaction history, correlate linked accounts, runs sanction checks and call into risk scoring models to get the score on the particular risk and then finally generate the summary, right. So, the model is actively deciding which tool to call, what is the order, when to retry, how to aggregate responses, when the investigation is completed. So, in other words, LLM has quite become the orchestration engine taking probabilistic model decisions and talking to downstream services to cater the requirements. So, that makes operational challenge, right. So, because every tool call, every retry, every routing decision, every piece of accumulated context impact to the cost, latency and predictability, right. So, let us move this process into put some numbers. So, here. So, these are rough token estimates that I came up with each steps. So, step 1, the model loads the fraud alert and then see what are the available tool manifests just to decide what to call, right. So, for that it consumes 30,000 input token and 2,000 output token. So, step 2, it first correlate the linked account. For that it rereads everything from the step 1 and previous API responses and again it reads the tool manifest to decide which tool to call in order to correlate the link accounts. So, that consumes 58,000 input token, right. So, look the pattern step 3 and step 4 which are sanction and risk scoring and generate the investigation report. You can see input token has been become 86,000 input token and 100,000 input tokens. So, that is how LLM works. LLM simply carrying the full accumulated context in each steps, right. So, one fraudulent investigation is not much complex, but the concern is the context accumulation issue. So, by the way, end up the workflow for one fraudulent investigation it becomes $2. It's nothing to worry, right? It's just $2. So that's why you are seeing it's okay, it's in prototype scale, that is totally fine, right? It's burned 2074,000 input token and 25,000 output token. So what happening is, the issue comes when this is runs at the production at the scale, right? So if something goes wrong, let's see how this $2 become $2 million in weekend, right? So imagine a recursive orchestration retry loop has been enriched into the process. What will happen? So if it is tried 1,000 times, simply the $2 becomes $2,000 amount, right? So that is still it's okay, but what happened in a busy weekend, if 1,000 of wallets landing onto the system, what will happen? $2 become $2 million in the weekend. So what is the issue? So simply APIs were healthy, right? So a model respond perfectly, and infrastructure did what it designed to do. Simply the architecture doesn't had no loop detection, no span cap, no session boundary, and no kill switch. There is nothing outside to look this kind of pattern and terminate the process, right? So that's the issue. That's why autonomous orchestration make a disaster at the production. So a simple failure can amplify the cost at machine speed, because there is no any human operator to operate this process, right? So when people say about the AI execution cost, what they are thinking? So they think they fix it on the model. There is a model problem like that. But actually, the issue is with the architecture, right? So context accumulation. So every workflow step expand the future context window, and every API response become more input token later, right? So second, autonomous retries. You know, agents or AI systems, anything, it's recursively retrying. So each retry multiplies both inference cost and downstream API cost. Third, workload depth. So more orchestration steps mean more reasoning cycles, right? So fourth, tool fan out. If the agent coordinate with low primitive type of downstream services, what will happen? Then it needs more tokens, right? So fifth is model selection. Every routing every task into the biggest model inflate the runtime cost for no reason. So model is doing what it was built to do, right? So all of these are architectural decision we made. Okay. So problem starts when the LLM is using as a execution layer. So once the intent passing into the LLM directly call into the raw execution primitives by taking probabilistic decision rather than taking deterministic decision. So that's once that happens, consequences are shown up together. So you lost deterministic control flow, recursive execution loops become possible, and hidden execution paths become possible, and governance becomes decentralized, and contexts keep accumulating, which all drive the token cost, right? So why does that happen? Because the whole execution happens with ungoverned probabilistic orchestration. That is the problem, core problem we need to fix, right? So once the execution becomes probabilistic and ungoverned, what we can see operational failure at the production. So you will see identity gaps, who initiate this, which session, and which user authorized to do it, likewise. So you get the retry storms. Agents recursively retry until it gets successful response or budget is exhausted, right? So you get invalid tool arguments because model generate parameters on the fly. So it could be contain hallucinate parameters, right? So And perhaps, so most importantly, you get no economic boundary, right? So a single execution path can consume enormous budget before anyone notice. So at this point, a natural question is, why can't we solve this problem using API governance mechanisms? We know, right? There are authentication, rate limiting, circuit breakers, and so on. Why can't we use them? Because the challenge is that traditional API governance was designed for request-oriented systems, right? So agentic systems bit different. So governance boundary has moved from individual request to entire execution session. So that's we are already seeing the consequences like this, right? These are not actual theory, these are experience in nowadays, right? So if you see in the left side, Gartner predicts 40% of AI agent project will be cancelled to 2027 because escalating costs, unclear business value, and inadequate risk controls, right? In the right side, you can see in unnamed company has reached the $500 million cost within 1 month, right? Real AI build, okay? So the challenge is no longer building AI systems, but it's governing the AI execution in production properly, right? So organizations can't simply slow down the AI adoption because AI is rapidly becoming part of the customer experience and internal business operations. So that creates tension. So we need to move fast, but we also need to govern the AI execution, right? So the challenge is that thing. So what will be the fix? So the fix is we need to apply separation of concern principle for the LLM-powered systems. Reasoning, governance, and execution should happen through 3 independent layers, right? So without control plane architecture, too many responsibilities sit inside the model boundary. So with control plane architecture, we can separate those responsibilities into 3 separate independent layers. So LLM, we can let the LLM to do what it does best, reasoning and planning. And we can move the governance concerns like identity, policy, limits, and spends those into control plane. And execution concerns like sequencing, retrying, those into the platform layer. So with that onwards, we can come up with a governed execution and control spend, full observability with predictable outcomes. So that is the solution we have to come up with. So let's see how this works here. So here 3 concerns, 3 layers, clear separation, right? So now see the problem into solution path. So I'll walk you through this 5-step path from architecture principle to production implementation. First, we design the system differently by exposing workflows, not the law primitives. Then we look at the runtime execution flow, where the agent calls single business workflow instead of orchestrating every steps itself. After that, we validate what changes when orchestration moves outside the model boundary, and then we add governance, runtime boundaries, budgets, and retry limits, loop detection, those kind of things into the step 4. And finally, we look how this control plane architecture works in practice at production, right? By the end of this path, the 5 cost drivers that I have shown you become bounded, observable, and governable, okay? So let's start with the design. So principle is simple. You have to expose workflows, not primitives. So on the left side, you can see how low-level primitives on fraud investigation are directly exposed into the LLM as separate tools, right? So LLM has to manually orchestrate all 5 tools and has to decide, order, pass the data between tools, retry upon failures, and combine result, and so on, right? So that is exactly how we get token growth, retry storms, hidden execution paths, and poor governance. So on the right side, in the better design, right, we define the predefined workflows outside the model. For example, we can define the API sequence of low-level primitives for the fraud investigation workflow using Arazo. I think you all heard about Arazo. So then we can wrap that workflow with one MCP tool, which can call investigate fraud case. So the LLM no longer sees 5 low-level tools; it only sees one business capability. So the workflow handles sequencing, the gateway handles the governance, and the model only reason and select the right capability. So that is the key shift: build the workflow and then register it with the gateway and let the LLM to call one tool. So the platform governs everything else, right? So now let's see how execution works. The agent sends the intent through the gateway, right? So the model still performs reasoning and select the appropriate business capability. So, but once this capability is selected, execution becomes deterministic. But once the gateway routes the request to the MCP server here, the server is then invokes the execution engine or workflow engine where has that executions deterministically, right? So LLM is still reasoning, but it is no longer orchestrating. So we now have the 3 separate layers: reasoning layer, governance layer, and execution layer. So that's the idea. So the important point is this: the architecture change we made is not magically remove every risk, but architecture creates the right control point. So that is the idea. So what we have done is we move the risk out of the model, and now onwards we can see the token growth. Token growth becomes visible, and because workflow execution is deterministic, and now onwards it's cacheable. And hidden execution paths becomes traceable through single workflow entry point with identity propagation. And retry storms become bounded because retry policies now can be enforced outside the model. And recursive loops now detectable outside the model. So the key point is, once orchestration moves outside the model boundary, the risks become observable and governable at the platform or gateway level. So the next question is, what controls actually make them governable, right? In production, governance is not a single feature. It is a collection of runtime controls continuously enforce cost, execution, and operational boundary. So the first, we need token counting and cost estimation. So if we can't measure the execution cost, we can't govern it, right? So second, we need session spend tracking. So budget should apply to entire execution session, not only to the individual request, right? So third, we need loop detection and kill switch. This is what we prevent the kind of recursive orchestration loop we saw in $2 million incident in the weekend example. So finally, we need the semantic workflow caching and deduplication. If 10 agents or 10 execution ask effectively the same question, the platform shouldn't execute the same workflow 10 times, right? So there are the runtime controls required for the production scale agents. So notice that none of these controls live inside the model, right? They are runtime controls enforced at the platform level and gateway layers. So this is why moving orchestration outside the model boundary is so important. Once execution becomes deterministic, governance becomes possible. That is the idea. So the next question is, where does this controls actually live? One practical answer is AI gateway. So AI gateway sits within the execution paths and becomes an enforcement point. So it can apply model routing, rate limiting, and guardrails, prompt management, caching, observability, and identity management. So most importantly, it provides a centralized space to enforce runtime policies consistently across models, tools, workflows, and applications. So the goal is not to replace workflows, the goal is to govern execution as it happens. So far we have discussed design, execution, validation, and governance, right? The final step is operate in the system at production scale. So at this point, the challenge is no longer executing single workflow. The challenge is governing hundreds or thousands of AI executions consistently, safely, and predictability and economically. So that's the idea. So here in this diagram, if you see, here is a key distinction. Your business logic stays in your own workflow and on runtime, right? The control plane doesn't absorb it. Governance wrap around the execution. The platform governs every request flowing through it without you to rewriting that your system actually do. So that is the idea, right? So cost efficient AI execution is not just about choosing a cheapest model. So production system needs identity boundary, policy enforcement, observability, spend control, blah blah like that. So runtime governance like this. So whether you implement this through a commercial platform or an internal control plane or a combination of tools, the principle remains the same. Governance cannot live inside the prompts, right? So governance must be centralized outside the model, right? So that includes AI gateway for LLM and AI traffic, MCP traffic, and first class identity boundary around everything that consumes the platform. It could be users, services, agent alike. So that is what enables LLM-powered system to operate safely and economically at production scale, right? So these 6 are the key capabilities needs for the control plane, right? So let me leave you with 4 key takeaways. So first, LLM cost and latency challenges are not often architectural problems. It's not often architectural problem, not model limitations. The model matters, right? But in production, the biggest cost drivers are usually context accumulation, retries, workflow, depth, tool fan out, routing decisions like that. Second, treating LLM as full orchestration engine creates operational risk. It leads to token waste, retry storms, hidden execution paths, and poor observability. So third, we need separate reasoning from orchestration. The LLM should reason over the intent and select the right capability. But deterministic execution layer should run workflows as governed tool. And finally, control plane architecture is what makes this practical in production. It centralizes identity, policy, routing, spend control, observability, and runtime enforcement. So probabilistic orchestration creates unbounded economic behavior. Control plane architecture restores bounded observable execution. So that is the principle my talk here. So I'll close this with, you don't have model problem if you are seeing this in production in your agent. So you have an architectural problem. The future of AI is scalable, deterministic execution. The future of scalable AI system is deterministic execution, governed capability, and cloud-native control plane architecture. So model reasons, the control plane governs, and the platform executes. So that is the idea. So here, if you can learn more in depth about the reference architecture is you can scan this QR code, and there is a one landing page. You can see whole idea on the solution path, and I really appreciate if you can provide the session feedback with scanning the right side QR code. So thank you.